Hello everyone, this is Manoj and I am from BB Raju Institute of Technology, currently pursuing my second year in the stream of Computer Science and Engineering. And now I am going to explain you about a machine learning model for house price prediction. Before getting into any machine learning model, there are three major steps to be followed that are analyzing the dataset. We should first clearly know about the dataset we are given and the problem statement we are given. According to the problem statement, the dataset will be given and we have to analyze all the dataset, what are the features given, what are the attributes of the dataset. And after analyzing the data steps, the required steps to be followed are pre-processing the data and cleaning the data. Sometimes the given data may be corrupted or may contain any null values. We cannot train our model using the dataset that are containing null values or corrupted values. So we have to clean our data using some pre-processing steps. After cleaning our data, we have to build our model and fit the dataset into our model so that we can predict the values. And now let's dive into the project. Before going into the project, let me show you the dataset provided for me. Here in this model, we are going to predict the house price for the Hyderabad location. So I am provided with the Hyderabad houses dataset. First column contains location. Second, here it is a supervised learning model such that the price of the houses are also provided in the data sets itself, and we have features such as total square feet, number of bedrooms, school availability, car parking and lift availability, and all the features of our data set. And now let's getting into the project. Here is a project. I have imported the basic libraries which require for machine learning such as pandas helps me to deal with the data sets and read the csv files and all those performing some modifications in the data sets would be helpful with pandas. And I have imported numpy so that I can perform any mathematical and numerical operations in our with our data. I have first loading the data. I have loaded the data using read csv, which is a method in pandas. And let's dot head dot head gives us the first five columns of our data set. And as I said, using null, if there are any null values in our data set, we cannot train our model with those null values, so as it cannot predict the values for the null input. So I have checked are there any null values in the data set. Here you can see I have summed all those null values. I have got 0 0 0. Location has 0 null entries in such a way that as I have cleaned the dataset previously, there are no null values in the dataset. Here data.describe method gives us the total information of our dataset, like mean of each column, standard deviation of each column, minimum value in that column, max value in that column. See, let's try to apply value counts of our location. See, there are how many distinct values of in our location column. If I try to apply location value counts for our location column, Kukatpalli has 166 entries, Manikonda has 115 entries, in all such that are the entries in the dataset. Here you can also see there are some locations with only one entry, like Mayuri Circle, Paradise Circle have only one entry. We cannot train our model with these such type of data as we have only one training data, so the output may not be accurate as there are only one training data. We can train our model only with one entry of Mayuri Circle, Mayuri Nagar. So what I have done is I have checked for all the location which have less than 10 entries, so that I can group all these values which have less than 10 entries into one entry, such that I have named the other entry as other. See, after grouping all those entries which have less than 10, I have got 4 6 8 other values. So I have placed all those into a one session like other, and all other are the entries of like Kukatpalli have 166 entry, like that. And I have included another column in my dataset like price per square feet, which could help me in predicting the values accurately. Price per square feet is nothing but the price divided by the total square feet into 1 lakh, as 1 lakh is minimum like standard deviation I have got here. In this total price I have got about 1 lakh, so I have multiplied it with 1 lakh. And it's important to remove outliers before training our model. What are outliers? Outliers are the bad entries in our data set, such that if we take an example of number of bedrooms, Here if in number of bedrooms, if there is any entry such that entries like, let's think of 100, there may, in Hyderabad there are no houses with 100 bedrooms, right? So it is a bad entry in our data set. So we have to remove all such bad entries from our data set. So I have removed square feet into outliers. So after removing the outliers, this is the data I have got. See, this is the data and mean value of each column and max value of each column I have showed using describe method. And now let's start building the model for our dataset. So I have placed all the features in X except price column. You can see I have dropped the price column and assigned all other columns to the X value, so it could work with me as features. And Y, I have assigned price to the Y. It is a label for our model. Start building our model. So for building our model, I have imported all the packages that are required. That I have imported train test split. This method helps me splitting a data into a training data and testing data. Using this method, the machine automatically splits the given data into training data and testing data using the size of the data we have provided. And I have imported models like linear regression, lasso, and ridge. These are the algorithms I am going to use in my project. And I imported one hot encoder and standard scalar. One hot encoder, I will tell you in coming steps what is one hot encoder and what is standard scalar. And I am using pipelines in this model so that we can perform all the steps, all the pre-processing steps in a single step. And I have imported R2 to see the accuracy of our model after predicting the values. See, now I have using train test split. I have splitted the data into training data and testing data, and I assigned to X train, Y train, X test, and Y test. Here I have given the test size as 0.1. It means that 10% of data goes into training and 90% of data goes into testing. Here you can see X dot train have X dot train dot shape. Using this method, we can see the shape of our X train. X train has 1766 columns and 1766 rows and 8 columns. And X test has 197 rows and 8 columns, which means that 90% of data goes into training and 10% for testing. And now let's start building our model. First I have using a column transformer. See, we have our location column as object type. We cannot perform the numerical operations on object type, so we have to convert this object type into an numerical type. We can make that possible using one hot encoder. There are many other encoders like label encoder, but here I am using one hot encoder so that I can perform conversion for all these many entries. There are many entries in our location column. Using one hot encoder, it could be simple for me to convert all these string values into numerical values. So I have made a column transformer so that we can transform total column using one hot encoder into, see, I have given location column to one hot encoder so that it could convert all the values of object data type into numeric data type. Here I have loaded standard scalar. Standard scalar is used to what we call standard scalar. Using standard scalar, we can bring all the values into a single scale such that there may be prices. See, here in price column, it consists of lakhs. If there may be into crores, there may even be crores, and even let's think of 1,000. So these are all different 1,000, lakhs, and crores. So using standard scalar, it brings all the values. Like let me give me an example. Like if we have entries in centimeters, in meters, and kilometers, using standard scalar we can convert all those into a single scale of centimeters or kilometers or meters according to our data set and model that we need. So that we use standard scalar to bring all the data into a single scale. And after standard scaling the data, I have loaded my linear regression model into linear RG variable. Using pipeline, as previously said, using pipeline we can perform all the pre-processing steps in a single step. See, I have made a pipeline of column transformer which is used for encoding the data, and standard scalar which scales the data and applies the model linear regression. See, I have made the pipeline and I am fitting the training data to the pipeline. After fitting the After fitting the training data to the pipeline, what happens is, in the first step is, it 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 goes to one hot encoder and encodes the location column, and it goes to the standard scaler and scales the total data, and it applies the linear regression model. And if we try to predict the value using pipe is just a method which runs all these methods, all these steps, if we call the pipe. And if we try to predict pipe.predict, it directly goes to linear regression, and it predicts the values from linear regression. And I have provided the testing data here. So using we get the predicted values. Using R2 score, we can check the accuracy of our data. Here, using R2 score method, I am giving X test, that is what are the values to be outputted, and I am giving the predicted values. So I have got the accuracy like 88.2. 88.2 is the accuracy, that is output correct. 88.2% correct values are predicted by our model. And now let's try to apply lasso. Lasso is also another model which could give the better prediction than linear regression. So I applied lasso model, given lasso model. In the same steps are followed. I have first loaded the lasso model, and I have made a pipeline of column transformers, scalar and lasso model, which for the steps involved in the pipeline are: first it encodes the, using one hot encoder, it encodes the location column, applying standard scalar, and applies the lasso model. And I have fitted the model, and I have using the predict lasso.predict, I have given that, I have provided the text data, and I have checked the prediction score. See, the prediction score is about 88.27. There's a slight difference like 88.26 and 88.27. So lasso has improved in points. And I have even applied the reach in the same way. I have made a pipeline and loaded the reach column. Steps involved: first encoding standard scalar and applying the reach model, and I have provided the reach model with testing data, and I have predicted the data. And see, at last I have printed all the values of lasso, linear and reach model I have applied, and all the R2 scores of each model. You can see linear regression predicted 88.26% correct, lasso 88.27% correct, and reach similar to linear regression 88.26% correct. So we can, from these all three models, a slide better is lasso. So I can choose lasso for predicting my house prices of in Hyderabad dataset. We can even deploy this. I have a deployed model of this. If we try to deploy, I have deployed this, and if we try to run this, streamlit run this our project name. See, after deploying, our model looks something like this. It shows the data sets first, and I will display the data set. If you want to see the training data, you can also see the training data by taking this and taking the inputs of total square feet, number of bedrooms, school availability, and all those, in such a way that we can predict the value. We can even deploy this model. For deploying this model, we can use a standard library in Python such as XGBoost and Streamlit. I have used a Streamlit framework for deploying my model. And this is all about the house price prediction using Hyderabad dataset.